Hello everyone. So today I want to show you my latest library, which is actually a Python shader library. I know it might sound weird coming from me because I'm a rigger, but basically I found myself in need to a nice way to basically handle shaders for animation. So not really complex shader like for rendering with really complex and connected maps and stuff, but just something like nice way to handling shader and quickly creating them, saving them, loading them, assigning them, this kind of stuff. Of course, needed to be done by code. Okay, so now I want to show you how I decided to write that because I kept in mind it has to be simple, but even though I wanted to write something which is easily expandable in order to support different shader or different data type and stuff, and has to be easy to expand and to deal with. Okay, so I will show you in a little how I did that, but first of all I want to show you how it works. So the first step is of course from our library to declare a shader class. Okay, right now we have two different available shader, a Lambert and a Bling. Okay, so those are Python classes. Okay, it's not a Maya shader, it's a pure Python class. So if we import those and let's create a Lambert, when we do that, Maya shader is also created, and I'm gonna tell you already and you will see that later. The Python class and the shader are automatically synced between each other. Okay, so for example, if I want to change the color, I can just access the color attribute on my shader class, okay, and set it. So if I do that, you see now I set a yellow color. So for example, let's assign the shader to the cube. So that's a yellow color. And you see, that's not a method. So I'm not calling a method to set the color. It's just an attribute. So means that manipulating the Python class automatically affects the Maya shader. So they are synced. And that's not hard coded. So I'm not telling manually every time, oh, I want to change that color, sorry, that attribute, change that, set the attribute. I I actually used a series of attribute classes which I will show you later. And of course, you can also set a texture if you want to. So for example, you see I set a blend now and automatically the needed nodes were created. And of course, I can change the class, sorry, the texture I want, or I can go back to the color and the nodes, the texture nodes are gone because we don't need them. And so set texture, and of course I can do that with other attributes. So for example, transparency. If I do that, now our material is more transparent. But the sync, sorry, works both ways. So for example, now I can ask my class, what's the color? And it will tell me, hey, you're using a texture which is a checker. If I change that to yellow back, it's gonna tell me, hey, you have a yellow color, 110. Okay, so you see it works both way. And for example, I can do that the same with the name. So you see I change the name of the shader, automatically sync that. Really easy, it works, that's everything. So now if we set back the default shader, okay, so this was the first step. Then of course I wanted a method to assign the shader dynamically, okay. Of course, if I want to I can even hardcode that, but I wanted to implement a way which can be a little bit more flexible. So I created some matcher classes. So by matcher I mean a class which is in charge to um, find meshes based on rules you give them. Okay, so for example, here we have two different matchers. We have a matcher based on a set, so a Maya set, and one based on a wildcard. So we can pass a wildcard expression like we do in Maya selection, and it's gonna return us the the meshes which pass those rules. Okay, and then the last step I did was to create a look class. So what I mean by that is just basically a class able to handle the shader and the matchers and to automatically handle all of that and apply the shaders. Okay, Why don't we give it a go? So let's create again. So let's get rid of this shader, I don't need it anymore. Let's create it again. Oops. So let's create it and again, let's give it a checker texture like that. Like it. Now I'm going to create two different meshes. One working on a set, because you can see here I have a set of cubes, 1 and 2, and another one using a wildcard where basically I want to parse uh, or basically get all the geometry which have capitalized cube in there, okay, somewhere. So you can see that we have cube 1, cube 2, and also cube 3, which is actually a sphere, okay. And I'm going to show you how we can play with the rules to apply different the shader to different geometry, okay. So let's create those matchers, like create them, and now let's create a look class and let's add a sub look. A sub look basically is just a tuple of matchers and shader, okay. So in this case I just want to use the wildcard matchers and the lumber shader, okay. It's called lumber, yes. So I add this sub look and now I say apply the look and let's see what happened, okay. So you see, it's applied the shader also to the sphere because the sphere is called has cube, capitalized cube in that. So if I ask the matcher, okay, what are the meshes? You see, it returns me all the three cube. But what about if I want to filter out these spheres? Okay, so what we can do, we can combine multiple rules together, and for example, we can add first the rule which says, okay, I want all the geometries which are inside the cube set. So in this case, polycube 1 and polycube 2. And then I want to add that from that set, I want all the geometries which have capitalized cube in that. Okay, so if I do that now, so let's create another look and let's give both the rules. First the cubes, the set, and then the wildcard. Okay, and apply that. You see now it applies only to the cubes because actually let me do something which is easier to understand. Let me add this cube to the set, sorry, this sphere to the set. So relationship editor sets. So I want to add this sphere to the cube, okay. So now if I say apply the rule again, it's only going to apply that to the cubes, because even though the spheres is inside the set, is not it doesn't satisfy the second rules which says, okay, it has to have capitalized cube in there, okay. So this is how the library works, and of course I didn't show that, but of course you can save and load the shaders or even an entire look. So now let's say this is my rig. I applied the shader and when I wanted and everything. I created actually the shader. I created the right rules. I just need to say to the look, save it, and then and it's gonna save a JSON file, and then I can load it back, and in 2 lines of code basically reapply everything correctly. Okay, so that's why it's a really simple, easy way to handle that, because once you find the right setup, the right shaders, created the right shader and the right matchers, loading them really is just a matter of 2 lines, and the library is gonna take care of everything else. Now let's have a quick look at the code and let's see how it's made, okay. So let's close that. So this is the library. You see we have attributes, matcher, look, utilities, and shader. Let's go by order. So let's have a look basically at the lumber shader. Let's see what we have in there, and you can see it's really simple, okay. So we are inheriting from shader class, which is actually an abstract class, and then we have some attribute declared, for example color, transparency, ambient color, conditions, whatever, okay. Those attributes are actually descriptor okay? And a descriptor, basically a generalized uh, decorator, let's say a generalized property decorator, okay? So if you don't know what is that, you can Google up. There are many tutorials about that. And basically the descriptor lets me implement a setter and getter method, so I can automatically handles the attributes or the data the way I want, okay? So by just simply declaring this attribute, automatically the shaders is able to handle automatically the sync from the attributes and everything, okay? um, and this is the sorry, this is the Lambert, and then we have the Bleen, which is actually inheriting from Lambert and adding extra attributes which are not present in the Lambert, so reflectivity and so on, okay? So same things applies from the measures. The measure works similarly, but let's see how an attribute is made. So for example, we have a generic numeric attribute which inherits from another abstract class, um, and then the only things I need to do is to implement the set and get value methods, which are called automatically from my class and then from Python, okay? So for example, you see I'm automatically gonna set the value or getting the value to the attribute I tell him to, okay? So this way it's really easy to set up attributes, add attribute, remove attribute I want to support. So I can actually give you a quick demo of that. So for example, let's see, let's let's create a Lambert, sorry, a Bleen, and let's see, let's grab, um, I'm actually supporting all the attributes, I think, from the, sorry, for the specular shading. So let's see in the Lambert, I think I'm not supporting the translucence depth. Let's see. So let's grab the attribute, copy, and let's see if in the Lambert this is supported. No, translucence depth is not there. So if I want to support it now, it's super easy. I just gonna add the attribute. So this is a simple numeric attribute, so a simple float. So I can just declare a numeric attribute. So I declare it. Here we go. And that's it. My shader now is able to support this attribute, okay? So now let's try it. So I'm just gonna reload the shader. I'm gonna create another Lambert. Here we go. And now I'm going to, oops, I'm going to manipulate the translucent depth. So let's see, I want to set it to 0. And here we go. This has been set. So let me grab the shader really quick. Which one is the one created? So lamp.name test2. This is actually, did I create a, hold on. Let me, okay, so this is actually test. It's here, it has been created. And now you see I set the depth to 0, okay? And all works. And now if I'm going to reload again, actually let me remove this attribute, remove it, and I'm going to reload, and I'm going to create, let me remove some crap, I'm going to create another Lambert test. And now if I try to set the translucent depth, nothing happened, you see, because basically now I'm just creating a value in the class, but this doesn't mean anything. It's not a custom attribute which I say I want to support, okay? So nothing is happening. It's not synced, sorry, or anything, okay? So you can implement really simple attributes, you see, like a numeric attribute, or for example you can implement a color attribute, or actually is the color attribute is what I call RGB attribute. You can see declared here RGB attribute. And the RGB attribute is a more complex type and is basically able, as you saw before, to handle both a texture class and a color, a simple float color. Okay, so again I can set the color again back and forth, and it's able to handle automatically a texture, create the nodes, remove the nodes, and everything. Okay, so you can implement really simple behavior like a simple attribute color, sorry, a simple value like, or a boolean value or a double value, whatever, or really more complex attribute. Okay, so for example, you see there is also the bump mapping, which it didn't support yet, because I will probably need to create a custom attribute for that, a custom bump attribute, because the bump is not only a texture, but it also required a bump node which needs to be created. So if you create a subclass, an RGB attribute, for example, or even you can create a new attribute and you can implement that behavior, and that's how the library works. So I don't know if I'm going to release the library yet, but I intend to. I just need to polish it a little bit more and getting ready, but that most likely in a little bit it will be on GitHub for you guys to play with or expand, give feedback, whatever. Okay guys, so that's it for now. Bye bye.